Hey guys, welcome back. Page 179 still in your Singapore 4A textbook. But this time we're going to look at part 2, the A through E. And the difference between the first problem and this second problem is that these involve mixed numbers, whereas the first one always involved just plain old fractions. So let's take a look at the first one. This one, I would say, it's definitely important to write it vertically. In the last type, there was just one thing to keep track of. It was the fractions. But in this part, we're going to have to keep track of the whole numbers and the fractions. So I like to write it vertically. So when we go out to the side, we're making sure that we keep track of both of them at the same time. So the first problem says 12 minus 7 5/9. So again, normally we would kind of break this up into two problems. We would do the whole number parts, subtract them, and the fraction parts. But if you notice here, there is 0 fraction up here, and you're trying to subtract 5/9 from it. That is a problem because we don't have anything to subtract the 5/9 from. So this is kind of like when we did borrowing or regrouping, where we're going to have to go from this column over and say, hey guys, do you have anything I can take from you? And the 12 will oblige, just like it did before. I'm going to take one of the two ones out of here and take that away. Now here's where things get a little bit different, because normally when we regroup, we take this 1 and we give it to the next column as a 10. Right? But we're not going to do that in this case because that's not the relationship between this column and this column. Right? Think back to earlier in the year when we did subtraction problems like 3 cups and 8 ounces minus 1 cup. Actually, these are weights. So let's say we had 3 cups and 2 ounces minus 1 cup and 7 ounces. And we would have to borrow from the cup, right? And we would come over here and we would say that this was 2 cups. But when we gave it to this, it was not, it's not a group of 10. The relationship between these is such that the ounces and the cups are not related the same way that we do when we do regular subtraction. So what we gave to this column had to deal with what the transfer rate was between these two. All right, so when we're talking about fluid ounces, actually we might have done ounces and pounds, not cups and ounces, but the transfer rate between these is that there are 8 ounces, 8 liquid ounces in 1 cup. And so when we give that 1, we would say we don't have 12, we only have 10, because the 1 single cup was 8 fluid ounces plus the 2 fluid ounces that we already have, makes this a total of 10. And then we can subtract. So we would say we have 3 ounces here and then 1 cup. All right. So again, it's the same kind of thing when we go to do fractions. That transfer rate, when we transfer from the ones column into the fractions column, is not a group of 10 like it normally is. And the group that we're going to transfer over is dependent upon either what's there already or what we're subtracting it from, what we're going to subtract in this lower column here. So we're going to say that we're giving this one whole fraction over here, but we're not going to say what it is just yet. Let me erase all this work here to give ourselves some more room. Okay, so now that I have that, now I'm going to say that I have 11 minus 7, again, because I took 1 away from the 12. But now what I'm going to do is I'm going to write this 1 as a fraction. I'm going to call it 1 over 1. And I need to write it as a common denominator, or as an equivalent fraction that has a common denominator with the 5/9. So instead of writing it as 1 or 1 over 1, I'm going to write it as 9 over 9. And then this is going to stay 5 over 9. Now, why did I choose to do 9 over 9 instead of 5 over 5 or 7 over 7? It's because I want to make sure that these two fractions have a common denominator. This has to be 1, so I could pick any denominator I want. So I'm going to pick the one that's like this one. All right, now I'm just going to subtract. So I've got 9/9 minus 5/9. That gives me 4/9. And then 11 minus 7, that one part's easy. I'm just going to put this dotted line here. 11, 10, 9, 8, 7. That gives me 4 and 4/9. Now, I'm going to check this fraction part to make sure that it's reduced. All right, again, 4 only has 2 and 4 as factors, and 9 doesn't go into either, or neither of those go into 9. So this just stays 4 and 4/9. Okay? All right, let's look at part B. Part B says 5 and 1/8 and 3 and 3/8. This one's pretty easy because they have common denominators already. So how about you go ahead and do that one? There's just one tricky part in that in this problem, and that is you're going to have to reduce your answer first. So pause the video and try this one and come back to check your answer. Okay, so the tricky part here is that when I add 1/8 and 3/8, it's not the denominator part. That is easy for us, but we get 4/8, and then here we get 8 and 4/8. But 4 and 8 do share a common factor. The factor that they share, the largest factor that they share is 4. And so when I reduce that, I'm going to say 4 goes into 4 one time and 4 goes into 8 twice. So this becomes 8 and 1/2. Now, you might not have realized it was 4. You might have said 2, in which case you would have done 4/8. And you would have said 2 goes into 4 2 times, 2 goes into 8 4 times, and then you would have realized that they share another factor of 2. So 2 goes into 2 once, 2 goes into 4 twice, and then you would have gotten a 1/2. So either way is fine, but just make sure that you don't leave it as 4/8, that you actually reduce it. Okay, part C says 4 and 5/12 plus 5 and 7/12. Again, common denominators, so this one's going to be pretty straightforward. So pause it and do this one on your own. Again, there is one tricky part about that, and that is the fraction part. When you get done, there's something you have to do to that. So go ahead and add them together and see what you get, and then come back. Okay, so they already have the common denominator of 12. When we add the 7/12 and the 5/12, we get 12/12, and then 5 and 4 is 9, right? This is not a proper fraction because the numerator is not smaller than the denominator. So we look at this and we say, well, what is 12/12? Hopefully you said it's 1. So this part is 1 plus the 9 that we have here makes this a 10. That would be our final answer. All right, did you remember to do that? Hopefully you did. Okay, part D. This is where things get a little bit more interesting. All right, so the problem says 4 and 3/5 minus 1 and 1/10. All right, so subtraction like the first one was up here, but we have to find common denominators here. This is our first time in this set of problems that we have to do that. So I'm going to focus on finding the common denominator first, and each time I'm going to carry the 4 and the 1 along. I don't want to just leave them out and then forget about them. So this is 4 minus 1, and then here I'm going to look at the larger denominator. It's a 10. I'm going to ask, does 5 go into 10, or is 10 a multiple of 5? The answer is yes, so that's our common denominator. This denominator is already set, so I'm just going to transfer the numerator over. But up here, I have to find another way to write 3/5 that has a denominator of 10. So in order to get the 5 into a 10, I have to multiply that by 2. And then I have to do the same thing to the numerator. So this becomes 6/10. So 4 and 6/10 minus 1 and 1/10. So I end up getting 5/10 here and 3 here. Again, I have to ask myself the question, is our fractional part fully reduced? And the answer is no, because 5 is something that goes into both 5 and 10. 5 goes into 5 one time, and it goes into 10 twice. So this becomes 3 and 1/2. That is our final answer. Okay, and then part E. This is 9 and 5/8. Oops. 9 5/8 minus 3 1/4. Okay, so I have to find that common denominator first. I'm carrying the 9 over, I'm carrying the 3 over. They are very patiently waiting for their turn. Then I'm looking for the common denominator part. So I look to the larger denominator and I ask, is 8 a multiple of 4, or is 4 a factor of 8? And the answer is yes, so 8 is the common denominator. All right, then I don't need to do anything to change the numerator. But here I do. So I'm looking for a fraction that's equivalent to 1/4 but has a denominator of 8. I need to multiply that by 2, that by 2. So I get 2/8. All right, now I subtract. 5/8 minus 2/8 is 3/8. 9 minus 3 is 6. I look to my fractional part and I say, is that reduced? Well, 3 is a prime, so the only way that this is going to reduce is if 8 also contains a 3, but it does not. So that's it. Okay, in the next video I will do parts F through I. So I'll see you in just a second.